Hey classes, if you check out the picture behind me, it comes from the book The Boys in the Boat. We're using some of it to talk a little bit about the subjects that we're checking out in biology class over the next week or two. Also, you know how I love to use little tidbits of stories because we remember things better when it's part of a narrative, and we're looking at The Boys in the Boat for a lot of reasons. One, apart from just being an inspirational and wonderful novel, also turned into a motion picture. If you look at some of the things that we talk about in this class, for example, we go through Newton's laws and some engineering concepts. When we had our guest scientist lecture here yesterday, they were talking about the idea of friction. And what better way to talk about friction when you're talking about the drag that's holding back the boat as they try and push it forward through the water. So you've got the fluid drag going on right here. We've got the levers themselves. The oars are levers. We're going to be talking in a little bit about the 11 human body systems. And when we go into the chapter on skeletons, of course, our skeletal system is a series of levers held together by ligaments and tendons, and we'll be talking about that. So a great place to talk there. And then also exercise. They're all using oxygen, and their mitochondria has to process through the glycolysis, through the Krebs cycle, through the electron transport chain. They have to take the sugar that they're taking in and turn it into energy so that they can row this boat in the first place. So it's a wonderful story to talk about these things when we're looking at the way things fit together. At the very beginning of the year, I used a little bit of the movie The Martian and the book The Martian because it talks about the difference between soil and dirt, and we'll get to that in just a second when we get to today's notes. So let me turn this off. I'll go quickly through today's notes. Today is a Friday, so we have our quiz. I always try and shoot for a quiz on the same day of the week all the time, so it's Friday this week. And it's an open note quiz. Before we had our quiz, we had our brain pop. I like to start with the brain pop. We're current events for most days, and we're looking at the organizational structure of this class. It's kind of a good time here at the beginning of the second trimester to talk about where we've been and where we're going. Here we've got cells combining to make organisms. So we're still studying cells. We're going to be lingering on cells for quite a while. Next week we'll be talking about, for example, fermentation, lactic acid, and a little bit about the winemaking industry here in California. We didn't quite get to that this week, but we'll be moving forward with that next week because that can bring together a lot of things about how we use our knowledge of fermentation to make much of the food that we consume. So we'll check that out next week. While we show the brain pop, remember interactive notes. When you see the 3 dots, that's for the students to fill in. And let's see what those dots were today. Cells combine to make organisms. Define an organ. What is that in the first place? And then here are the 11 that they went through on our 5-minute video. I just asked the students to write down any 3. And one of the ones that, of course, was a gimme here was the skeletal system because we talked about that in class in terms of the boys in the boat and the boys pulling the levers. When we get into the second part of the class, the students then took a quiz and had a couple notes to get down. I will go into a little bit more detail on the friction part. With the notes where I can go through and highlight them as we talk about the way that fits in with our understanding of mechanics. But this was an overview of where we started the class and where we're going. I'll start down here and work my way up. We started with the start, the Big Bang. So I'll shift this just a little bit. 14.5 billion years ago, the beginning, as we know it, of our universe. If you look at the formation of atoms from the subatomic particles, and hydrogen mainly after the Big Bang, the 4 forces of nature, the 4 fundamental forces of nature, gravity, electromagnetism, the strong force and the weak force, pulling hydrogen together to make the first stars. This class is about evolution. It's about the increasing complexity. It's about the way that we organize things in a hierarchical fashion, going from atoms up to molecules. Now you'll see slightly different organizational hierarchies depending on your subject, but for our subject, mainly biology, we talk about why do atoms combine in the first place to make molecules? Where did all those different elements come from? That, of course, we went through with the stars and the way that they fuse hydrogen to make the heavier elements. And the molecules getting together to make monomers, single units that then make polymers. The most important by far of those are the amino acids that get together to make proteins. Proteins, as we're learning in cells, do virtually everything in a cell. A protein, when you're talking about the protein functions within a cell, one single human cell, or eukaryotic cells, have tens of thousands of proteins that do a variety of tasks, bringing things into and out of the cell, putting together other proteins, transporting things around, aiding in the reproduction of the cell. We could go on and on for literally thousands of tasks that proteins provide. Moving on from there, cells themselves, the basic structure of life, the basic structure of an organism, going from cells combining to make tissues, organs, and organ systems. That ties back in with the organ systems, the 11 that we'll study in class. Sometimes you'll see in books they have 10, sometimes 12. We're going with the 11 human body systems. For example, you've got the cardiovascular system. Sometimes you see books break them apart into 2 separate systems. Other times they combine them into one. We're going with the 11 system organization chart because that's the most popular. And from there, when you're talking about organisms, the way the organisms get together in communities and an ecosystem, and finally, the most important thing, the thing that we're studying in this class, the one thing, I have to spin around here, the biosphere, the encompassing part of the planet where all living things, not just on our planet, but where all living things insofar as we know right now in the universe reside, this little thin biosphere on Earth. Tonight, if you get a chance to look outside, there has been a gorgeous, gorgeous, gorgeous crescent moon. Of course, it's a waxing crescent, so it's getting a little bit bigger from our point of view every day in our sky. And right near that crescent moon, you can see the bright planet Venus. Looks like, of course, a bright star in the evening sky right now. Sometimes it's a morning star, sometimes it's the evening star. Right now it's the evening star. Check that out. If you want to see one of the reasons that we are trying to understand our biosphere, is a major theme of this class is the human impact on the environment. And one of the things, when you look at Venus, it's got a mean surface temperature of about 900 degrees Fahrenheit. That's everywhere around the planet. That is an extreme example of what happens when you have too many carbon dioxide-like molecules in the atmosphere holding in the radiation from the sun. As this radiation tries to escape in a different wavelength, it can't escape. It's like adding blanket after blanket after blanket. And that is what we are doing to our planet. Us humans right now, by burning fossil fuels, are essentially adding blankets and keeping our biosphere warmer and warmer. Warmer than it would naturally be, even given cycles of temperature over the vast geologic history of the planet. So one of the most important things that if I had to sum it up in just a few sentences in this class, we're studying an ongoing study of evolution, how you go from atoms all the way up to organ systems and an entire biosphere, and then also our responsibility as humans to protect our biosphere. At the beginning, we were talking about Mars, a little bit of comparing and contrasting. When you've got saying, hey, we're going to move to Mars, we're going to get colonies on Mars, we're going to live there. No, we've got a biosphere on this planet that has taken 4.5 billion years to get to this point. Everything from when we talked about Mars not having the required protection from the solar radiation, the heavy solar particles, to talking about the amount of liquid water that we have here on Earth, to simply talking about the amount of gravity and resources that we have on this planet. Our entire job as citizens, as biologists, as scientists, is to understand our biosphere so we can protect it. So that's where I'm going to leave it today. Look for the notes online and make sure that you have an updated notebook for this second trimester. I always suggest to students this might be a good time to start a new spiral-bound notebook, one for each trimester. This would be a good time going forward to see where we're going with cells and the level of organizational hierarchies that we're studying right now. Okay, have yourself a great weekend. Enjoy your 3-day weekend. I'll see you back here on Tuesday.